This is the third video of Unit 3, and we're going to deal with our complex vector problems. Complex vector problems are anything where their two vectors or more are not at 90 degrees to each other. So things are not north and east. They would be north and 65 degrees south of west, or two things at an angle. So they're much more complicated, and they just take a very different process, because the Pythagorean theorem doesn't work. There are other mathematical laws, the sine law and the cosine law, that will allow us to do these problems, but we'll look at that in grade 12. Right now we're going to follow one process where we have to deal with our components, just like we learned about last video. So we have to add all of our x components and our y components, and then deal with a third component vector at the end. So there's a lot of different steps here, and we'll go through it one at a time. So as usual, write down the information, sketch, and do a whole bunch of math. So we'll walk through these steps one by one step at a time with our example. Two people are pulling on a tree. First one exerts a force of 15 newtons at an angle of 35 degrees east of north, and the second pulls at a force of 16 newtons north. Find the resultant force on the tree. So start with what we know. We know F1, our vector, is 15 newtons, 35.0 degrees east of north. F2 is 16 newtons north, and what we're looking for is FR, our resultant. Okay. Step 2, sketch a vector addition diagram. I'm actually going to draw two diagrams. The second one will be the vector addition diagram. Sometimes it helps to draw this first one, which is just what is going on. So here's a tree, or at least looking down at a tree, and we've got one person pulling straight north. So here's a person pulling straight north, and this will be F2. And then we'll have F1, and we've got another person over here pulling at F2. So we've got two people pulling on this tree, and we're trying to figure out what the result force is. So what does the tree feel based on these two people pulling? So a vector addition diagram is just like it always has been, drawing one vector after the other and then drawing a resultant. So that would look like this. Our first vector is 15 newtons, 35 degrees east of north. So that's at some angle this way, and this will be F1. Then our next one is due north, so straight up, F2, and then our resultant is over here, FR, at some other angle. So a very complicated diagram compared to what we've seen so far. But we can do it. I know we can do it. So now we got to resolve each vector into its x components. So let's look at the components of F1 here, and then the components of F2. So starting with F1, let's draw a diagram of F1 just on its own. So we'll have this diagram here, and we're 35 degrees, so 35.0 degrees east of north. So let's draw in our components that would make up this one, and then we've got F1, Fy, and Fx. Now, if you got comfortable with figuring out fx and xy, you would know that fx is the f1 times the sine of 35.0 degrees, and it's sine because it's the opposite side. Fx is the opposite side. So it's, again, looking for patterns. And so if we plug in our numbers, that would give us 15 newtons times the sine of 35.0 degrees, which is equal to 12.29 newtons, and I'll put a mark under there for where the sig fig should be so we have some indication. And then Fy and F1. And if 1 is sine, if x was sine, then y has to be cosine 35.0 degrees. So 15 newtons times the cosine of 35.0 degrees. And that would give us 8.604 newtons. And again, a mark where our sig fig should be because there should be 2. And you've got Fx and Fy for component 1. So I should put a 1 in there so that we know that we're dealing with our F1. Now F2, let's draw F2 all on its own. F2 is easy. Why is F2 easy? Well, F2, remember, is 16 newtons due north. So if we think about F2x, there is no east or west, so that makes it 0 newtons. And then F2y is just 16 newtons. Now let's make sure we've got everything positive and negative if they should be. So we have one that's going north, and so that should be positive, and the other one's east and north, so that both should be positive as well. So everything is positive so far. We've got our components. Whew. Done a lot of work, still more to do. Step 4 and 5 are very similar. We've got to add the x components together and add the y components together. So let's move down to the next page to do this. So what we're looking for is we're looking for frx, which is f1x plus f2x, and fry, which is equal to f1y plus f2y. So plug in our numbers for frx, and we get 8.604 newtons plus 0 newtons. And again, so that's easy, 8.604 newtons for frx. Fry, 12.29 newtons plus 16 newtons, and that will give us 28.29 newtons. And again, keeping track of our sig figs with a mark underneath each time. And okay, now what? Now we're on to, so we added up our x's, added up our y's. Now we've got to draw a new diagram with our two resultant components. So frx, so we'll draw this one, 8.604. It's positive, so we'll go 8.604 newtons that way. And then fry, I'm going to move that down because I'm going to quickly run out of space. And fry is also positive, so we'll draw that one straight up. Try to make it longer because it's definitely longer, but it's not terrible if it's not really to scale. So we got frx, fry, and really what we're doing this entire thing for is to get what fr is. So we're finally seeing fr somewhere. Now remember, we got to draw our angle theta. Whew. Two things that we need are fr and theta, so we can get our final vector. We're almost there. Now we got to do a little bit of trig. So remember that fr would be the square root of frx squared plus fry squared. Okay, a little bit of trig here, so plug in our numbers. The square root of 8.604 newtons squared plus 28.29 newtons squared. And you do that one out and you'll end up with 29.57 out of your calculator, and it will be to 2 sig figs in that one. You can do that one out to see how it gets to 2 sig figs. But we're not going to round it yet. Just leave it there. It's fine. We got to figure out our theta. Now, we want to use fry and frx rather than FR. So what you'll always be doing in this case is you'll always be doing your tan inverse of those ones, of your angle. So theta equals your tan inverse of FRY over FRX. And we can do that calculation. So we get 28.29 newtons over 8.604 newtons. Both of those are 2 sig figs, so our angle is going to be to 2 sig figs, so 73.1 degrees. 2 sig figs, mark underneath. We've got FR, we've got theta. We can finally make FR as our final resultant vector. We're almost there. So, we need 2 sig figs from 29.57, so that's going to round up to 30. Make sure it's 2 sig figs using scientific notation. And our angle is also 2 sig figs, so 73 degrees. Now we got to figure out what our direction is. So let's look at our diagram here. And our angle has gone north of an east vector. So FRX is pointing east, and we've moved north of it. So our angle would be north of east. There we go. That is our final answer to that problem. There is a lot of steps, but as long as you follow those steps, so those 9 steps there are very useful as you're getting comfortable with these types of problems. Follow them out, do it step by step, and you won't have a problem. Watch this video again if you have to, but take a look at the problems and see how they go for you.